Now, we're going to use calculators in our example. So let's start off with this calculator, and I clear the register. And let's take 1 divided by 7, or 1/7. And if you can read that, if you have a high-definition version of this video, you should be able to read it. It's 0.142857,143. So I wrote that down here, 0.142857,143. Now, if you were actually measuring something, do you think that these later digits would actually have any significance? Do you think you could measure something to that degree of precision? Well, there are situations in science where, as a matter of fact, you can, but that would be very, very rare. And in ordinary, everyday practical math, probably if you had 0.143, that would be all the significant digits that would matter. Chances are you couldn't really measure it any closer than that. And indeed, 0.14 might even be adequate for most situations. As a matter of fact, I usually set my decimals to show a couple of decimal places at the most, just for convenience. With this calculator, you can do that very easily. This second key, this yellow key, if you press it first, will then perform whatever is the operation above the keys. And you probably can't see this on the video, but above the decimal point is the word fix, F-I-X. So if I hit the second key and the decimal point, that's going to fix it. And if I hit 2, that will fix it at 2 decimal places. So that would say 1/7 then is 0.14. If I hit it second fix 3, that would show me 3 decimal places, 0.143. And in fact, I can have any number of decimal places. There's 5 decimal places. If I want them all, I just hit the decimal point twice. Now, I like to set my calculator for most calculations at 2 decimal places. It depends on what I'm doing. There are times when I don't want to see any decimal places. For example, if I was taking 367 times 589, I really don't care about those 2 decimal points, so I would fix this at 0, and the answer would be 216,163. That's the way this particular calculator works, and I think with any decent calculator, you ought to be able to fix the number of decimal places. So what I encourage you to do is to use your common sense. If you are taking a measurement or you're expressing a number, you decide how many of the digits actually have significance, and that's how many you use. I like to tease my wife occasionally. It'll be, say, in the morning, and she'll say, what time are we going to do this afternoon? And I know the answer is around 2:30, let's say. So I'll say something like, 2:37. And of course that kind of annoys her because that clearly implies more precision than I could possibly probably know. So you can have a little fun with that sort of thing if you want to. In any event, real numbers are the numbers that correspond to a straight line, as I've already said. And anytime you get a real number, you can locate it on the line, or any point on the line corresponds to a real number. Here would be 0.5, for example. Here would be 2.5. Pi is 3.14 approximately, and so forth. Now, the last thing I'll say is that depending on who you're learning your mathematics from, you can get into a lot of theory with real numbers. I'll just give you a couple of examples. The square root of 2, for example, is what is called an irrational number. It's also called an algebraic number. This is in addition to be called a real number. And that has a certain theoretical meaning. However, for us, we're always going to just simply look at the approximation of it, which would be 1.414 if we want to use that many significant digits. Now, this is not the actual number, square root of 2. This is approximately that number. In fact, 1.414 is itself a rational number, and it's an approximation of the square root of 2. The fact that it's irrational and that it's algebraic for most ordinary computations doesn't really make much sense, doesn't matter to us, and we're not going to worry about that. That's a theoretical thing. An even more profound example is pi, which is the circumference of the circle divided by the diameter. We'll learn that when we talk about geometry. Now, it turns out that pi is a real number, but it's also a transcendental number, whatever that means. And I'm not going to tell you what it means right now. It's also an irrational number, and that just means it's not rational. So these are names that are attached to it, And in fact, it wasn't until a little over 100 years ago that we could even prove that it was a transcendental number. By the way, that means that it is a real number that is not algebraic, if you want a quick definition. But what we're going to always use is an approximation of pi. If you take your calculator, this happens to have pi on it. And if you hit pi, and we're located to 3 decimal places, that's 3.14. Now you can extend that out if you want to, and you can see that it's many more decimal places. In fact, it is 3.141592654. And in fact, there are computer programs where you can plug in pi and actually see it out to 1 million decimal places. But of course, for practical purposes, you don't need very many digits. In fact, the farthest out you probably would ever want to go in a real life problem would be 4 decimal places, 3.1416, and usually 3.14 would be enough. But that's another example. Now, we will have another video sometime, probably, particularly if you ask for it, where I'll talk a lot more about the theory behind it. But as far as we're concerned, all you need to think about is real numbers as numbers that you can enter into a calculator, and you can correspond to points on a real number line. So this is Dr. Dell signing off, and I'll see you at the next video.